Everyone, and welcome to my YouTube channel. So here today we are going to be looking at the mole concept and stoichiometry. So many students find this difficult, but this is one of the easiest topics under chemistry. So now, what is the mole concept and stoichiometry all about? So stoichiometry is just the use of ratios in a balanced chemical equation to be able to predict the mass, volume, concentration, and the number of moles. So just as we have said, we are going to be looking at a balanced chemical equation. With a balanced chemical equation, we can be able to predict anything. We can predict the mass, we can predict the molar, the moles, the concentration, and the volume in a balanced chemical equation. So now, the molar mass is very important for us to also understand. So the molar mass is just defined as the mass of 1 mole of a substance. So that is our molar mass. Let's take this example. So if you have, let's say, your hydrogen plus your oxygen to produce 2 moles of water. So in order for you to know, let's say you are told to calculate the molar mass of hydrogen, it shall be this 2 that is here, times the molar mass of hydrogen, which is 1.01 grams per mole, which will give us a value of 2.02. Now remember, the molar mass is the mass of 1 mole of a substance. So that is very important, 1 mole of a substance. So if you have something like this, you are going to look at how many moles. Here we have the 2, so we are not going to multiply by 2 because the molar mass only shows you 1 mole of a substance. So to understand the mole concept and stoichiometry, let's take this as an example. Let's say you have 1 cup of flour, you have 2 eggs, and you have half a teaspoon of baking powder. So now what you get is 5 pancakes. You also get, let's say, 2 fritters. So now the mole concept and stoichiometry simply tells you what you are going to get at the end of the day for each and every reaction. So that means to say, as long as, let's say, these are the ingredients. Now, as long as, let's say, all these other factors are available, as long as you have 2 eggs, it is already known or predetermined to say you are going to have 5 pancakes, like that. So as long as 2 eggs are available, you're going to have 5 pancakes. As long as you have half a tablespoon, you are going to always have 5 pancakes. As long as you have 1 cup of flour, you're always going to have 5 pancakes. Likewise, this means that as long as you have half a tablespoon of baking powder, you are always going to produce 2 fritters. As long as you have 2 eggs, you are always going to produce 2 fritters. As long as you have a 1 cup of flour, you are always going to produce 2 fritters. So the idea is, for whatever you have as a product, you are always going to be able to predict how much of the product is able to be produced if you have a certain amount. So now this is the idea. That means to say, if you have, let's say for this one, you need 1 cup. So you are going to say 1 cup of flour. So you are going to say 1 cup should be equal to, what do you have? You have 5 pancakes. So as long as you have 1 cup of flour, you are going to have 5 pancakes. Now, as long as you have, let's say now you choose to increase to 2 cups. So as long as you have 2 cups, that means to say you are always going to produce x times 1. So as long as these are on the same side, you can cancel them. So x times 1 is x, should be equal to 2 times 5. We have pancakes, like that. Pancakes. So this is going to produce 10 pancakes. So in other words, the mole concept can be used to predict how much of the substance you have provided with one substance. So it just depends on what they want you to find. That means to say, if you have 2 cups, how many fritters would you produce? same idea. So you know to say as long as you have 1 cup, you are always going to be producing 2 fritters. So you are going to say 2 fritters. How about if you have 2 cups? If you increase to 2 cups, you are going to produce, you don't know. So you are going to cross multiply this x times 1. So this cup goes. X times 1, it will give you x should be equal to 2 times 2. So it will be 2 times 2 fritters like that. So you can be able to quantitatively be able to determine how much you are able to produce by increasing one of the factors. So the more concept, if you think of it in this way, is very, very, very simple. Now, if you look at it from this other question, let's say you have money. If one item you sell it at 5 kwacha, that is the amount you sell it. That means to say if you have 20 items, how much you're going to make from these 20 items? X. So x times that, you are going to have your x should be equal to this 20 times 5. So you have times k5. This will always give you a value that is equal to 100 kwacha. So as long as you have 20 items, if each item is 5, you're going to make 100 kwacha, which makes sense. Now let's look at it from the other perspective. Now. Let's say you have the actual question. Let's say you have iron is extracted from its ore, iron 3 oxide, by reacting it with carbon monoxide according to the equation. So now this is the actual question and how it comes. Now, let's calculate the number of moles of carbon monoxide required to produce 35 moles of iron. So what you compare with is determined by how much information you have. So what they want is calculate the number of moles of carbon monoxide required to produce 35 moles of iron. So carbon monoxide, we have this one. So we can be able to say from the equation, so the number in front are the number of moles. From the equation, we can establish that. Calculate the number of moles of carbon monoxide required to produce 35.0 moles of iron. So you just compare with your equation to say how much carbon monoxide do I have. So the amount of carbon monoxide that I have, I'll be able to say 3 moles of carbon monoxide shall be able to give me, since they have given me the products for iron, I'll be able to say 2 moles from the equation first, because the equation gives you a template of what you are expected to have as long as the equation is balanced. Think of it as our pancake example. So you have 2 moles of iron. So that is what you have. Then you are going to say, how about if I have 35 moles of iron? So the 35 belongs on iron, so you are going to put 35 moles of iron like that. Then you are going to cross multiply. So when you cross multiply, as long as these are the same, you can cancel them, this and this, if they are on the same side. So you can have 2 times x, you are going to have 2x should be equal to, we have these 3 moles of CO, you multiply it by 35. So this gives us a value of 105. When we multiply 3 times 35, 105 moles of CO like that. We have a 2x, we divide 2, our x value should be equal to, when we divide our 105 divided by 2, this gives us a value of a 52.5 like that. So these are the moles of carbon monoxide. So with that idea, you can be able to answer any more concept question like that. So it's very, very easy. Let's look at our next problem. Our second part says, determine the number of moles of iron 3 oxide that react when 4.5 moles of carbon dioxide are formed. So same approach. So they are talking about the moles of iron 3 oxide. So you are going to say, from the balanced chemical equation, you have a 1 there. So you are going to say 1 mole of iron 3 oxide should be able to give you a value of, according to the equation, it's 3 moles of our CO2. Then you are going to say, what if you have produced 4.5 moles of CO2? So you are going to put your 4.5 where CO2 is, moles of CO2. Then here, you don't know how much can be used, so you are going to say X. From there, cancel this, cancel that. We are going to have our 3 times X. It will be 3X should be equal to, we have a 1 times 4.5. 1 doesn't change anything, so it will be 4.5. Then moles, we are remaining with this, moles of iron 3 oxide, like that. Then we are going to divide over our 3, so our X value should be equal to, we are going to divide our 4.5 divide by our 3. This gives us a value of a 1.5. So we are going to have 1.5 moles of iron 3 oxide. So in this way, it is very, very easy. Take note that we are not using the knowledge of limiting reagent simply because we are just given one thing, maybe the product or just the reactant. The limiting reagent is only used if you have been given the amount of substances used for 2 reactants at the same time. If they give you the amount used for iron and the amount used for carbon monoxide, then you can use the limiting reagent. But if they haven't given you both at the same time, you can't use the limiting reagent. Our third one is saying that using the equation, answer the following. So we have, calculate the mass of iron 3 oxide in grams required to produce 0.570 moles of iron. So to answer this one, we are going to do the same. Now remember, they are asking for mass. Now for this video, we are not going to do our mass to mass calculation, but we'll just stick to our mole to mole. In another video, we can do calculations using the mass to mass. But for now, let's stick to our moles, then convert them. So according to this, what we have is, let's first find calculate the mass of iron 3 oxide in grams required to produce. Let's first find the number of moles for this. So we are going to say, so we are comparing our iron 3 oxide with our iron produced this side. So now, if that's the case, what we are going to have is that we are going to say, according to the equation, we have, if we have 1 mole of iron 3 oxide, like that, this will always give us, according to the equation, 2 moles of iron. So 2 moles of iron, like that. Then we ask ourselves, what if you have 0.57 moles of iron? So here you are going to do X, cross multiply. You are going to have your 2 times X. So since these are on the same side, just cancel them. So we are going to have 2 times X. We have a 2X, which should be equal to, we have a 0.570 times 1. 1 doesn't change anything. So what we are going to have is, we are going to have something like a 0.57, like that, moles. We divide this, so moles of iron, Fe2O3. So we divide by 2. what we are going to remain with is our x should be equal to, we have our 0.57 divided by 2. This gives us a value of a 0.285 moles of Fe2O3. So now they want the mass. So if you have the moles, it's easy to find the mass. We know that the number of moles is equal to the mass over the molar mass. Now recall that the molar mass of iron 3 oxide can be calculated as follows. So we have oxygen, there are 3 oxygens, this number. We multiply by the molar mass of oxygen, which is 16 grams per mole. When we multiply this, we are going to get 48 grams per mole. Then also we have 2, we multiply by our molar mass of iron, which is our 55.85 grams per mole. We are going to have a value that is equivalent to, so 2 times 55.85, this gives us a value that is equivalent to 111.7. So we have 111.7 like that. So now what we are going to have is just that space has run out. Then we add the 2. So when we add them, we are getting a 159.7 grams per mole like that. So we can use this formula now. We can use this formula now to calculate the mass. So we know that the number of moles is equal to mass over molar mass. When we cross multiply, mass times 1, it will be mass should be equal to the number of moles times the molar mass. So the number of moles is 0.285 moles times the molar mass, which is equal to 159.7 grams per mole like that. So what we are going to have is 159.7 times 0.285. This gives us a value that is equivalent to so our mass should be equal to a 45.5145 grams of these substances, iron 3 oxide. So remember the molar mass, in case we need to recall about it, we are just going to be using the direct figure since we have already found the molar mass. So let's look at our next problem. So we are asked to find the number of moles of carbon monoxide needed to react completely with 48.5 grams of iron oxide. So the approach is the same. So you look at this, they want the carbon monoxide required to react with our hematite like that. So what we are going to do is we are going to do a mole to mole ratio. So according to the question, we have, as long as you have 1 mole of iron, it can be able to react with 3. That's what the equation tells you. Remember our earlier example on baking powder. As long as you have 2 eggs, according to what we had, it can be able to react with 1 cup like that. So for the first part, let us be able to determine how many number of moles of carbon monoxide are needed to react. So how many moles are in 48.5 grams. So that is what we are first going to find out. So according to this, we are going to say the number of moles is equal to the mass first over the molar mass. Now remember, what we are looking for is the number of moles of our Fe2O3 like that. So we are going to have our mass, which is equal to, we have a 48.5 grams like that, over, we have our molar mass. So our molar mass of this, we found it to be 159.7 grams per mole. So when we divide this, we are going to get a value of 0.304 moles of our iron 3 oxide like that. So this is the number of moles that are present in that amount. So with that said, let's now compare using our mole to mole ratio. So according to the mole, find the moles of carbon dioxide needed to react. So as long as you have 1 mole of iron, it can be able to react with 3 moles of carbon monoxide. So we are going to say 1 mole of our iron. Let's do this. 1 mole of our iron 3 oxide shall be able to react with, according to the equation, we have 3 moles of carbon monoxide, so we can be able to say 3 moles of carbon monoxide like that. Then we ask ourselves, how about if you have 0.304 moles of iron 3 oxide, so if you have 0.304 moles of our iron 3 oxide like that, so this is equal to our x. So we are going to cross multiply. So this mole, since they are on the same side, you can just cancel them. So we are going to remain with 1 times x. It will give us x should be equal to this value 0.304 times our 3 moles of our carbon monoxide. So the number of moles it's giving us is equivalent to 0.912 moles of our carbon monoxide. So that is the number of moles, but what have we been asked? Yeah, it's the number of moles, so we end there for that problem. This one says, the last one, calculates the mass of iron in grams produced when 18.6 grams of carbon monoxide reacts. So the same approach, let us first find how many moles are present in this amount. So what we are going to say is that we have the number of moles is equal to our mass over our molar mass. So carbon monoxide, which is our CO, we are going to have our CO like that. Then we have the molar mass of oxygen is 16. The molar mass of carbon is a 12.01 like that. When we add this, we are going to get a 28.01 grams per mole like that. Then we are going to have number of moles should be equal to our mass, which is this 18.6 grams over the molar mass. Remember, the molar mass is just the mass of 1 mole of the substance, so it doesn't matter what value is here, we don't multiply. So the number of moles is found to be equal to 0.664 moles like that. So these are the moles that are present in carbon monoxide. So now when you do that, be able to calculate now what are them. First, what is the mole? What are the moles of iron that are to be produced? So you can use your balanced chemical equation. So since you are dealing with carbon monoxide, so you compare 3 moles of carbon monoxide will give you 2 moles of iron. So you are going to have your 3 moles of carbon monoxide will be able to give us 2 moles of our iron like that. Then what we are going to have is that, what if you have 0.664 moles of our CO? We don't know how much of the iron we are going to produce, so we are going to cross multiply like that. Then 3, this one and this one goes, we are going to have 3 times x. It will be our 3x should be equal to 0.664 times our 2 moles of our Fe like that. So what we are going to have is our 3x should be equal to, we have a value that is equivalent to this 0.664 times 2. This gives us a value of 1.33 like that. From there we divide by 3 we divide by 3, we are going to get X to be equal to, we divide by 3, this will give us 0.443 moles of which substance? We have our ion there. Recall that they want the mass. So you can be able to say the number of moles is equal to the mass over the molar mass. Then you are going to say cross multiply. So our mass times 1, it is mass, should be equal to the number of moles times the molar mass. The number of moles is equal to 0.443 moles of Fe. Then we multiply by the molar mass of iron, which is our 55.85 grams per mole. So when we multiply this, we are going to get a value of 24.723 grams like that of iron. That means to say we have calculated that. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.